All right, so let's revisit the idea of the view and the model, right? We spent quite a bit of time talking about the view, the controller, and the model, and one of the things I would like to point out is actually that the controller, right, that is shuffling data back and forth between the view, between the model, is actually perhaps a version, right, or an example of using this adaptive pattern that we just introduced, right? It's a special case, right, where the view perhaps might want to have access to the model, right? But we know all the bad things that could entail, right? And we add this controller in between to be the traffic cop that goes between these two, right? And so we'd like to revisit this idea of the view and the model, right, where you have the data model play the role of the gatekeeper of the mutation of the data that does all the validation and maybe has some business logic and makes sure that the data is always consistent. There's no redundancy. That is easily retrievable, stored properly and whatnot. And then you have the view that doesn't really care how the data is stored, how it's represented. It only wants data that it can render for human consumption. And so we talked about the idea that we have this controller in between that is shuffling data back and forth. The ideally we don't allow the view have access to the data, right? That ideally instead we force in this architecture an additional artifact in between these two that mitigates this relationship between the view and the model. Okay. We said that the controller is the best thing what we could do. The controller knows where to fetch the data. It knows any transformation that it might need to do. Perhaps flatten something that's very hierarchical, flatten it into something that's easier for the view to iterate over. Perhaps only has a subset of the data type. The data model might have thousands of search results, and the model says, well, display these 10. Display page 1, page 2, page 3. This subset of elements. So the controller is the one who's responsible for this. The view is a dummy implementation that is only there as a consumer, right? The controller says, hey, just display this, right? So the view doesn't even ask for any of this data. It's being pushed. The controller pushes this data to the view for the view to then render, right? We put in between this controller that implements a controller interface, right? And it's the traffic cop between the model and the view, right? And we sold this idea to you quite a bit as a great solution. In this design, we refer to as mentioned earlier. The controller is following a strategy of pushing the data to the view, right? It fetches the data from the model and then pushes it to the view. Now it's a little bit inefficient, this strategy, since you might be pushing a lot of data repeatedly to the view. There's no caching. There's data that the view might already have that I might be pushing. The view might have 10 items that it's rendering, and and I just removed one item, and I update the model so that the model doesn't have this item anymore, and then I would then maybe push back to the view again those 9 items, or those 10 items missing one of the items, and the view would have to perhaps render them again, right? And the view says, well, wait a minute, I already had the other 9. Why am I re-rendering all 9, right? If I already have them, wouldn't it be more efficient if I could just update the view with just that one missing element, right? Why bother re-rendering all the 9 items that I already have? So a more efficient strategy might be for the view, knowing what has happened, that you just only removed that one item, and to say, hey, I'm only going to pull the data that I need. Right? I know what I have rendered. I only need to update this one little item over here. So I'll just pull the data that I need, as opposed to you pushing the data that might be more than I expect, more than I need. So So yeah, so a more efficient solution might be for the client, for the view, to pull only the information that it needs for rendering. Okay, but that would entail for the view to perhaps have direct access to the model, right? And we've said that that's a no-no. And so let's look at strategies that might perhaps give us the best of both worlds, right? That instead of the controller being so responsible for everything, perhaps have some help from the view, right? Yeah. So we're looking to consider a better solution where the view, knowing exactly what's rendered and what the human is consuming, perhaps pull some data, only what it's needed, only the subset of the data that might be needed for rendering, and perhaps give it some reference to the model, right? But we've sold you the idea. That's a very bad idea. There's a lot of pitfalls for the view to have any access to the model. Because the model, it might, certainly the interface that the model implements might have not only getters, but it might have a whole bunch of mutators, right? A whole bunch of setters, or add, or remove, or all sorts of methods implemented in the model that might mutate that model. And there's a lot of reasons why we don't want to give the view direct access. So what we could do perhaps is to give it a subset. Perhaps implement an interface that might only expose the read-only operators, right? Read-only operations to the view, so the view could only perhaps read from the model, but it could never perhaps update the model, right? It could not mutate the model. So let's explore that idea. Because we know that we don't want to mutate. We don't want the view to inadvertently change things, because it might circumvent some validation. It might circumvent some business logic. It might not. There might be multiple views on the same data, right? One of them is rendering as a graph. Another one is rendering as a pie chart. Same model, right? But different views rendering the same data model. So if one of the views can update, right, can change something in the model, it could be affecting how other views represent the same data. Yes. So we don't know what the propagations of this might be. So certainly we want to. We don't want the view to have mutation. So instead, perhaps we could give it some restricted access to the model. Right? Maybe we give it some access, but not allow it to mutate. So no mutation. So to explore this idea, we're going to look at an interface, right? We're going to call it the ViewModel interface, right? That's going to explore this idea. That's going to expose some of the methods in the model, but certainly not the mutators, right? Only read access to the view, and it's implementing the interface A ViewModel. It's going to allow extracting data, right, from by the client, right? In this case, the view, but avoiding, right, any mutation to the model by the view. In UML, it might look something like this. We have the view, has access to a view model that implements this A view model that presumably only has read-only operations. Right? I can read data. I could never mutate it. I can't change it. The model itself does have access to the model. Right? It has access to all the access, but it only exposes interfaces that are only read-only. Okay. Right. So this is basically the same idea that we just talked about, right? This is kind of the same idea of the adapter, where we are implementing providing an interface for the view, right? That is exposing only certain aspects of some implementation, that I'm expecting to be able to read, but not modify. So it's basically using this strategy of the adapter pattern, right? And again, it could be either by inheritance or by composition. In this particular case, we're going to look at implementing using an object adapter, right? Where we have an instance to the model. We have an instance to the model, and then we we implement the interface by shuttling or forwarding these methods to the model. Okay, it's an adapter to the model, right? It's a model adapter. Another way to implement the same thing is to have perhaps our view model and the model both implement the same interface. Okay, where you have both the view model and the model implementation both implement the model interface. The only problem with this implementation is that the view model presumably is also going to implement the mutation methods, right? And it would expose those mutation methods to the view. Right? So certainly, perhaps this might not be a good option, right? Because certainly the model implementation has access to all the setters and the add and remove and whatnot that mutate the model, and we would be exposing it through the view model. So perhaps this might not be a good idea. Or what we could have is that we could invert the whole thing. Instead of the view model implementing the interface to the model interface, what we could do instead is to have the model implementation implement the view model interface, right? The other way around, right? Like this, where the model implementation obviously is implementing the model interface. It has access to all the setters and the getters and all the mutators, right? But it also implements this view model interface, right? That provides only the read-only operations that are accessible to the view, and then the view only has access to an implementation that only has the read-only operations, but does not have any access to the mutator. So it's kind of inverting the same idea, where the model implements both interfaces, which is okay, right? In Java, you can implement multiple interfaces. Right. So this was just to say that the model view controller examples that we've been looking at for the whole semester, right, are examples of using the adapter pattern, using these interfaces to give some limited access to the view.